So first of all, as we all know that what is aquaponics and why we need aquaponics. See, at present we are having a lots of problem inside this agriculture and fisheries and aquaculture. The main problem is that we are having a very limited resources. We are having a limited lands on the earth. As we all know, about 3/4 of earth is covered by water and 1/4 is only having the land. So now it is the time to look upon the water body or utilize the water to have a food. So basically, aquaponics. See, aquaponics is basically nothing much. It is the combination of aquaculture, that is the raising of fish or prawns inside water, and the hydroponics, in which we grow the plant in water without soil in a very symbiotic, in very harmonious manner. So what we basically in aquaponics we used to do the soilless culture of plants or any vegetables with the use of fishes. So this aquaponics is very much similar to the hydroponics. In hydroponics, what we have is that we generally used to have growth plant inside water with some addition of nutrient inside the water without having the soil. But inside this aquaponics, what we usually do is to combine the fish culture along with the uh, agriculture or horticulture, in which the horticulture or agriculture is the main primary focus and fish farming is the secondary one. In the case of aquaponics, the waste produced by the aquatic animal, like fishes, is supplied nutrients to the plant and grown in a very hydroponically manner. This plant used to purify the water, and this purified water again used to fish tank. So this is a very closed loop system which mimics a natural ecosystem. What we see in natural ecosystem is that uh, this aquaculture or horticulture or agriculture, they're all combined. So in this aquaponic system, basically the resource is very conserved method for fish production because everything is just recycled. So there is nothing waste. It's a zero waste system. So some of the traditional system like paddy cum fish culture, in which like we used to have fish inside the paddy field. Suppose in the case of paddy farming, we have water inside the agricultural land for more than 3 to 4 months. So what we used to do, we used to add fishes inside the paddy culture, and simultaneously fish grow with the paddy. So this concept of aquaponics has been arise from seeing this the paddy cum fish culture from China and Thailand. Next, see, uh, one slide before. Yes. See, what is this? Basically, the aquaponic system. As you can see here inside this photograph, we're having a fish tank, in which there is water and fishes. The water from fish tank is basically pumped by the use of air pump, and it will go inside a bed which is having a plants, and this water which having the waste of fishes, it will go in the system where the plants are there. The plant will take the nutrients inside the water, and the remaining water will go inside the sump. So this is the basic system how the aquaponics works, in which nothing in which the aquaculture, that is the fish and plants, grow together without having the soil. Next. Yes. What is aquaculture and aquaponics? See, aquaculture is basically the farming of fish inside any water body, like you can say a pond, RAS, bioflok, any system in which we have fishes inside water, that is aquaculture. But aquaponics is that we have a system in which there is the hydroponics plus aquaculture. See, in the case of aquaculture, we are having the very high density of fish because we only going fish. So if we are having a high density of fish, then only we can have high yield of fish. But in the case of aquaponics, our main target is the horticulture or agriculture, while this aquaculture or fish farming is the secondary one. So in aquaponics, we go with the low stocking density, that is the low number of fishes per unit water area. Second is the water usage. See, in case of aquaculture, where there is only fish, there is a very heavy circulation of water, because in the aquaculture system, if you are having a high density of fish, that means they need high amount of feed. If you will give high amount of feed, then this water will be contaminated, or you can say more waste will be generated inside the aquaculture system. But in the case of aquaponics, because the fish density is very low, and we are also having the plant that will utilize the waste from inside, from the water. So in aquaponics, we used to go with the low stocking density of fish, and we are having a plant that will utilize the nutrient from the water. Third is the economics. We all know that in the, we can say, closed aquaculture system, it's very costly, but in and it's having a very high risky and high profit. But in the case of aquaponics, we're having two components. First one is the plant, second is fish. So there is the less risky, and since the horticulture or agriculture is the primary focus, there is very less amount of risk inside the aquaponics. Next, yes, hydroponics. So, what is the basic difference between the hydroponics and aquaponics? As we all know, that hydroponic is a system in which we grow agriculture or horticulture crops without having soil. So, in plant need nutrients. So, in case of hydroponics, we used to add the nutrient from outside. But in the case of aquaponics, the nutrient is from the aquacultural waste. So that is the basic difference between the hydroponics and aquaponics. Next is the water usage. So in case of hydroponics, we constantly needs to can say recycle the water, because whatever nutrient we have added inside the hydroponics, if it will have a higher load, it will damage the plant. But in the case of aquaponics, since there is plants to filter out the waste material, so there is a less circulation of water, or actually we need less amount of water in case of aquaponics. Third one is the pest and diseases. If we add some minerally, some high amount of nutrient or some other thing, it may cause disease. But in the case of aquaponics, since plant is there, so the by means of rhizofiltration, by the filtration to the roots of plant, there is very less chance of disease outbreak. And since there is no soil in the case of aquaponics, so there is no much contamination from the soil. Next, this is the main topic, that why we need to have aquaponics. Actually, we have so much amount of land where you can do horticulture or agriculture. So why we need to do aquaponics? This is the very can say the main point, that why we need to have aquaponics at present scenario. So first one is the saving space. As we all know that with the burgeoning, I can say, very high population density or very high population growth, there is a very less amount of land, and in that land are not suitable enough, or not can say enough to produce the food for entire population. So we need to look upon something alternative of this agricultural land, and this aquaponics provides a very good alternate to this uh, saving space. See, in aquaponics we can do vertical farming. So if you do vertical farming, then you can make utilization of the 3D use of this space. In agriculture, we only do the 2D, that we only used to grow the horticultural or agricultural plant in the two-dimensional, that is on lands. But in case of this aquaponics, we can use the 3D space, and we can have more yield of fishes. We can yield more amount of horticulture or agricultural in a less space. Second one is the no weeding. The main problem inside agricultural land is the weeds. So in agricultural land, we constantly need to remove the weeds, because weeds compete with our target species of agriculture or horticulture. But in case of aquaponics, since there is no soil, there is a very less chances, or you can say negligible chance of having weed inside the aquaponic system. Third one is the no soil pest, because soil pests are mostly originated from the soil. And in the case of aquaponics, since there is no soil, there is no chance, or can say almost negligible chance of having the soil pest. Fourth one is the no watering. In case of agriculture or horticulture, we constantly needs to add the water. But in the case of aquaponics, since it's having a collaboration of fishes and with hydroponics, so there's constant availability of soil inside the aquaponics. Fifth one is the source of income. By having the aquaponics, anybody in the urban areas, they can have some additional income by having the aquaponics on their rooftop, their balcony, or any space. Sixth one is the plant grow faster. Since see, since there is a no soil, there is no contamination, or you can say no growth. You can say hamper. So in case of aquaponics, we used to give the nutrient in a very simpler manner, and this nutrient is get absorbed by the plant in a very efficient manner. So if you compare the plant growth is much higher in case of aquaponics as compared to the traditional agriculture or horticultural. Seventh is the less energy. See, in case of aquaponics, we can use this solar power or some other means of energy, and since we can grow the plants in our nearby, so there is less need of transportation, there is less need of packaging, so we can save energy by this means. These products from the aquaponics are very healthy since there is no you can say contaminants or some other disease causing agent. So these products from the aquaponics are very good nutritive and very healthy, and it's also sustainable because mainly thing is that we are facing the shortage of water. Although we are having the 70% of earth surface with the seawater, but that is not suitable for humans. So we need to conserve the fresh water, which is only about 1 to 2% on the earth surface. So if in the case of aquaponics, we used to make the maximum use of water. See the water in which the fish is there, fish we will feed the fish with some feed, and that feed will be taken by the fish, and the fish will excrete out the extra nutrient, and that nutrient will be utilized by the plants. So there is the reuse of water, and the aquaponics is very sustainable things. Next, so main thing is how this aquaponic system works. So the basic system inside aquaponics, as I have told you earlier, in this system, what we have a fish tank in which we are having a fish. Second one is the rotation or cycling of water. Third one is the bed or media in which the plant is there, and fourth one is circulation. So water from the fish tank will go to plants, and the extra water will again return to the fish tank. This is the basic principle inside the aquaponics. So inside the fish tank, fish are raised. That's very simple. Fish produce the waste in the case of ammonia. So whatever feed we will give to fish, it will have protein, it will have carbohydrate, it will have fat and other things. So whatever protein inside feed is there, fish will utilize that protein, and the end product or waste product made inside the fish from the protein is the ammonia. And this ammonia is very toxic to the fishes, and this ammonia can be you can say break down by the plant in the case of in the form of nitrate or nitrite, and the plant can utilize the nitrite and nitrates. Second one is the water cycling. Water cycling is very important inside aquaponics because water containing the fish waste is pumped from fish tank to growing beds where the plants are there. Third one is the grow beds. Grow beds are basically the beds in which the plants are grown. The microbes are present inside this bed, which converts the ammonia from the fish waste to the less toxic nitrate or nitrites. And they used to also clean the water by this process of biofiltration. Next is the water circulation. The water circulation is very much important. The clean water from this plant will be pumped into this fish tank. The fish will take the feed, and again the waste from the feed, fish will go to the plant. So this is having a very mutual relation between the plants and fishes, in which the nutrient is recycled and both get the benefits. Because fish get the clean water, which is cleaned by plants, and plant take the nutrient from the wastewater of fishes. So both the fish and plant get benefited, and they have a mutual relationship inside the aquaponic system. Next, see, this is the mechanism of aquaponics. As you can see, the first process at the starting point inside the fish tank. This in the picture it is in the form of aquarium, but in practical it can be any round tank or tanks in any forms. I will give you details about this fish tank also later. So this is the you can see the first step. Inside the fish is there inside the tank. The water from the fish tank, it will be pumped out to the sedimentation tank where we'll having the primary filtration or screening. And again, this will be pumped to the biological filter in which the nitrifying bacteria will break down the ammonia into nitrite and then to nitrate. And this water will be pumped to fish to the plant tanks, and what and the this nitrite or nitrate will be utilized by the plant, and the water will be again come to fish tank. So this is the basic principle of aquaponics, how the system works. Next one. Huh. And the same thing I have told you, like first step, we will feed the fish. Fish will utilize the feed, and as you know that whatever feed we use to fish only utilize 30% of feed given to their growth. That means, suppose we are having the fish inside tank and we give 1 kg of feed for the fishes. So fish will utilize only 300 grams of feed to their growth. Rest 700 grams of feed will be either not utilized by the fish, or it will come as a matter of fecal matter. So what will happen about from the 700 grams? So these unutilized feed or the fecal matter from the fish, it will go to a growing bed of plant where it will be utilized the nutrient, and the rest water will come inside the some tanks. So this you can see fish water from the fish tank will pump out from the into the plant bed. Plant will take the nutrient, and the same water will be cleaned and it will come to some tank. Next slide. Next slide. Next slide, please. Khushi, next slide, please.
I think sir slide is showing there. Sham sir?
No, no, it's stuck on this photos aquaponics diagram.
Uh,
Next slide.
it's
Yes, yes, yes. So this is how aquaponics works. That means, as you can see, the fish are fed with the food. That feed will produce the ammonia. That is the fish waste. That too much waste is very toxic for the fish. That is ammonia. That the high amount of ammonia is very toxic to the fish, and fish cannot withstand, or you can say tolerate the high amount of ammonia. So this ammonia will be break down by the use of nitrogen bacteria into the nitrates and nitrites. This plant will take the nutrients, and again uh, this water will be filtered out, and it will be utilized by the plants. Next slide. Ah, this is the biological component of aquaponics system. See, the main biological system are like the fish, which produce the waste, the bacteria, the plants, and this uh, like water flow. Next slide. Ah, the main components of aquaponics, as you can see, I have told you what are the main components. Like the main components are the fish tank, the clarifier, the biofilters, the oxygen system, the sump tank, the pipes, growing bait, plants and fish, pumps and bell siphon. These are the basic components, and you can have alternates to each and every components. Next, see fish tank. So inside aquaponic system, what should be the ideal system? See, we are talking about the ideal system, but in our scenario, we can have alternate or you can modify as per our objective, as per our resources or as per our budget. So, so for the fish tank, it should be round. So why it should be round? It should be round because if it is round, it will have a very good stability and the water can be easily circulated. So if you have a very, suppose if you have a square tank or rectangular tank, there will not be enough circulation. If a body is circular, we can have a very good circulation inside the tank. So what we prefer in aquaponics is the round tank. And that tank should be have a very flat bottom. Why flat bottom? If the tank is having the flat bottom, the waste will be easily accumulated inside the bottom. So we can easily just pump out the waste and clean the waste from the tanks. Third is the light colored. It should be light color because if the tank is having the light color, we can easily identify where the waste is there. Because if a tank having the water, the visibility will be somewhat lesser. So if you're having a very light color, we can easily identify where our fish is there and where the fish waste is there. So we can easily take out the waste from the tank by some siphoning or you can say airlift mechanism without disturbing or without damaging the fish. Fourth one is the covered from top. This tank should be covered from top because to reduce the contamination, dust, or any predator should not go inside the tank. So it should be covered. It should be covered by any means, by some net or some many things. Fifth one is this tank should be very durable because we're having a fish and lots of water, so it should be durable. It should not be corrosive. Suppose we're having the tanks made from metals or iron, it may have rust after some time. It may be toxic to the fishes. Suppose we are having a metallic tank. In a due course of time, this iron will be leach out from the tanks to the water, and the iron content will be higher. So it will hamper the plant as well as the fishes also. Next one, the tank should not be damaged by sunlight because sometimes if you're having the FRP tanks, sometimes it may get damaged by the UV light or some scorching light. It may lose its color. So this tank for in the aquaponic system should not be damaged by sunlight, and it should have a proper drainage knob so that we can drain the excess water in case water will be up to brim or some overflow can will be there. Next, the clarifiers. Clarifiers are basically the settling tanks. That means it is used for the settlement of waste and the continuous removal of solid from the tanks. They generally, the clarifiers tanks are basically used to remove the solid particles or some suspended particles from the system. Next, biofilters. See, biofilters is you can say it is anything that is non-toxic to fish, non-toxic to plants. Suppose you are having any plastic wheels. The main purpose of biofilter is to give a substratum to the bacteria. It can be of any shape, any size, anything. Because if it will have a rough, the rough body will have more grooves. So more bacteria can be settled inside on the roof. The main principle is the adsorption. Adsorption is basically the surface attachment. है ना? Suppose if you are having any balls or any you can say net-like structure or anything or pebbles, stones, anything that will have a rough structure and the bacteria can be easily settle on that structure. So biofilter can be of any shape and size. Main thing is that it should be non-reactive, non-toxic. It should have a very high surface area as compared to volume. More surface area means it will provide more area to develop the nitrifying bacteria, which will help to convert the ammonia to nitrite and then titrate. Next, and next is the oxygen pumps. In case suppose you are having a very high density of fish, it will have a very high amount of waste, and that total waste will not be utilized by the plant at the time. So in that case system, you can use the oxygen system. Suppose whatever waste is there, it will be break down by the bacteria, and bacteria utilize more oxygen as compared to the plants. So it's very surprising. Suppose if there is a less amount of oxygen, bacteria won't survive. So we need to have oxygen inside water so that bacteria can flourish. They can divide in a very short time, in a very large number, and they can work well. So this oxygen system is very much necessary to provide the optimum amount of pure oxygen inside the tanks. And this pumps is there to pump out the water from fish tank to plant bed, and from water from the plant will be drained out to the sump tank by the means of gravity. Suppose you are having a fish tank, fish waste will be pumped out with the help of pump. It will go to plant bed, and from the plant bed it will come down by the means of gravity. We need not to pump the water from plant bed to the sump tanks. Okay, it will come by the gravity. Next is the standpipes. It is for the continuous flow of water, and some tank is there. Water from the plant bed. It is the lowest system where the water will be there, and this again water will be used for the fish tank. Next, bell siphon. See, if you will see the first slide, you will see the bell siphon. Bell siphon is a very much essentially component in almost every types of aquaponic system. Later, I will tell you about the different types of aquaponic system. So we are talking here about the media-based aquaponic system. That is, uh, uh, in this system, we're having a fish tank, and this water from the fish tank will go to any media bed in which plants are there. So this what happens with the bell siphon. Bell siphon is that when the water uh, fill the grow bed, the level of water mark inside the tank and inside the bell siphon will be equal. It will rise at the same rate. This bell siphon will regulate the amount of water flow and helps to move the water from media bed to fish tank. I will elaborate all these things when I will teach you the media bed. You just see the main principle is to the control water. By the means of bell siphon, you can control how much water you need to drain from the plant bed and how much you need to retain for the fish tank. Suppose by the means of bell siphon, you can control amount of water that we utilize by the plant and the water that you utilize by the fish. So this bell siphon helps to, you can say, promote the optimal nutrient balance inside the system and prevent the excess water inside either plant or fish tank. Next, grow bed. Grow bed is nothing but a bed in which we used to have plants. It must be studied, and this should be non-toxic to the plant. Suppose you are having a bed made up from the stones or gravels. Anything that hold the plant is called the grow bed for plants. So this anything that is sand or you can say gravels, anything can be which is utilized for the to just hold the plant. It will be called as grow bed. Next, see, this is the basic types of aquaponic system. Basically, we are having like three main system in aquaponics. That is the nutrient film technique (NFT), the deep water culture, and third one is the floating raft techniques. So if you can see here, there are six diagrams. That means they are basically six types of aquaponics. It can be more depending upon the situation. So I will elaborate these six for you. Nutrient film technique, that is the NFT. It- As you can see here, uh, there is a tank that is a nutrient solution in which fish is there. This water from the fish tank or in diagram that is nutrient solution, the water will be pumped inside a hollow inside a pipe in which planted there in a cups. You can see here this bed is slightly slanting. You can see here this slanting bed will help to drain out the water in gravity manner. Suppose it will have a like this in a same height, the water will not drain. So we are having a slightly slope. So by the means of slope, the excess water from this pipe will be drained out to the nutrient solution or fish tank. So water from the fish tank will go to a pipe in which planted there. Suppose a cup is there inside planted there, and from the holes from the bottom of cups, the roots are emerging. So when the water will flow inside the pipe, the plant will take the nutrient from the water, and the excess water will drain to the nutrient solution or you can say fish tank. Next one, you can see the deep water culture. In deep water culture, you can see here that the plant roots are directly touched with the fish tank or nutrient solution. This is the basic difference. In nutrient film, plant is above, there is no contact of direct water with the system. Third one is weak system. Weak system is like you can say Mm, Deepak, we have see the candles. Na? One candle, we are having a bati in which this like simple system in which uh, this excess water will be taken by the means of this wicks or bati. Suppose you are having a liquid. If you pour some cotton inside that, what we see by the means of capillary action, water from the tank will go up. So same thing happen here also. The nutrient from this nutrient solution will go up by the means of wick or any, you can say rope or anything that will lift the water from bottom to top. Next one is the ebb and flow method. This ebb and flow method, this water is uh, pumped by the means of timer. The difference between the nutrient film and ebb and flow is that in case of nutrient film technique, there is a continuous flow of water. But in the case of nutrient, in the case of ebb and flow, the water is pumped after 1 hour or half an hour. There is a fixed timer. That means after a half an hour, the water will be pumped like a tide. Suppose tides come at a different time. So again, in the case of ebb and flow, after every half an hour or any fixed time, the water will be pumped and then again it will come through the gravity. Next one is the drip system. Drip system is that the nutrient solution will be dripped by the means of, you can say, a drop by drop system to the plant bed, and that plant will utilize this nutrient in the case of drip system. And in the case of aeroponics, what we used to do, we used to make a very, you can say, mist or very foggy things by the means of nutrients like fogging. So this plant will absorb the nutrient by the means of mist or spray or anything. Next. So as I've told you, I've told you about six types of aquaponics system. The mainly three types of system is very much popular uh, nowadays. So in that, many One is the media-based aquaponic system. So this is the basic system in which the water from the fish tank is just pumped to a plant bed, and the plant utilize nutrient. So in that system, the flooding of plant media with a proper drainage channel uh, connected with the fish tank. And in case of media filled unit, uh, it is a very simple, efficient, adaptable method for the small scale of aquaponic system. In that media system, what is the main thing is that suppose you are having a media of gravel, stone, sand, anything. So what it will do, it will also hold the plant. Suppose you are having stones or gravel inside a glass, and you just pour the plant inside that cups or glass. What the media will do, media will hold the plant. And apart from that, since there is void inside this media, it will also help the bacteria to grow on this media. So this media bed, it also holds the plant, and it also provide a space for the bacteria to grow on it. This is the main principle or main thing of media-based aquaponics system. And in that system, you can use any types of fishes like IMC, catfishes, or you can have a, a plant like a potato, brinjal, okra. So in that media system, since there is lot of nutrient absorption, water is easily get purified or cleared. So in that system, you can have a plant like potato, brinjal, okra. But in other system, if there is low amount of nutrient, you can only have the leafy vegetables. But in case of media system, we're having lots of nutrient trapped by this media and plant. So in that system, you can have any types of small plants like potato, brinjal, okra, and other things. Next one, yes. Next one, as I've told you, the water from the fish tank will be pumped from by the use of pump, and it will come down by the means of gravity. The media will support the plant growth. It will also help the bacteria to grow on it, and it also help the biofiltration, because biofiltration is nothing but a filtration by means of biofilter or anything that help to grow the bacteria on it, and that break down the ammonia to nitrite and nitrates. So this bed can be made from any strong, durable food grade substance, because uh, if you will not have a food grade substance, it may hamper the quality of plants. Next, so in media based system, what we mainly focus to choose any types of media which have a very high surface area to volume, because it will have a high surface area, it will allow more bacteria to grow on it, and it should not be reactive to other things, because it will be reactive, it will hamper the plant growth as well as the animal or fish. So it should be inert, it should not be non-toxic, it should be non-corrosive, or it should be inert thing. That means the chemical should not be reacted with it. And sometimes what we used to do, we used to also add the worms, because if we add the worms inside the gravel, it will help to break down the waste in a very easy and efficient manner. Next, this is that you can also have a additional media, because suppose you have filtered this water by the means of biofilters or by the means of media. If there is some excess amount of waste, it can be absorbed by the means of some sponges. So if you want, you can also have a spawn at the end, so the water will get purified by the means of a sponge. Next is the nutrient film technique. See, nutrient film technique, it is a technique of aquaponics in which the plants are grown in a very narrow channel. Because, like, suppose you are having a pipe, you just cut down the pipe horizontally in the into two halves, and that can be used as a substrate for nutrient film technique. That means the nutrients are in a very small layer of water. So in that, a thin film of water continuously flows, uh, and this water flow continuously from the fish tank through the filtration component inside the nutrient film technique. In the nutrient film technique, a separate biofiltration is required. You know why? Why we need to have a separate biofilter in the case of nutrient film technique, but not in the case of media bed. See, in the case of nutrient film technique, what we usually have, we do not have any media. That means water will flow continuously. There is nothing to stop the water, or there is nothing uh, to give substratum to the bacteria. If you have, in the case of nutrition technique, we're having a separate channel, or you can say separate compartment, where we used to have lots of biofilter, and that biofilter will help to uh, uh, grow the bacteria and break down the ammonia to nitrite and nitrate. So basic difference between the media bed, in media bed we are having a media, it helps the bacteria to grow, and this bacteria will help to break down the waste. But in the case of NFT nutrition technique, we have a separate compartment where the water will be stored, and that fine bacteria will break down the waste from ammonia to nitrite and nitrates. Next, as you can see here, the water from fish tank is to uh, pumped to a plant bed, and here only plant's roots are there. Water will directly touch to the plant roots. Whatever nutrient is inside the water, plant root will take. See what happens inside. Uh, Water, there is continuous flow of water. So, it, so the nutrient is not taken by the plant in one time. So seriously, automatically water will flow, and plant will take nutrients very slowly, slowly. And if the plant will take the waste very slowly, the waste will take very much, needs some extra time to decompose. So in that NFT technique, we have a separate compartment where we used to have a mechanical and biological filtration unit. Next, see, as I have told you, this NFT technique is not suitable for all plants. It's only suitable for the green leafy vegetable. You know why? It is because in the case of nutrient film technique, the waste decomposition is very slow, very slow. So the waste is not utilized by the plant in a very efficient manner. So in that NFT technique, we mainly used to have the leafy vegetables, leafy things like basil, tulsi, corianders, mint, and other leafy vegetables like spinach and other things. But in the case of media bed, we can have potato, okra, uh, tomato, anything. So basic thing is that in media bed system we can have any types of plant, but in the case of NFT technique we can have only leafy vegetable because the waste decomposition is very slow in case of NFT as compared to the media bed system. Next, see, third one is the deep water system. So in the deep water system, it is also called the raft system because the roots of the plant are directly touched with the water. Suppose if we're having a fish tank, fish is inside the water, we used to feed the fish, and this uh, fish will eat the feed and it will create the waste. This wastewater will be recycled, and these roots will be in touch with the tank. Suppose you are having a fish tank, you make a thermocol sheet or any raft system that will flow on the water, and it will have a hole. In from the hole, the plant root will be touched with the water. So inside deep water system, we need to have uh, water circulation, because whatever waste will be generated by the fish, it will be in the bottom. It will not be directly taken by the roots of the plant. So this water should be recycled or circulated, so that the whatever nutrient reside inside the water, it will be taken by the plant in a very efficient manner. And it's also a very most commercial system of aquaponics. It is also used for growing some leafy vegetables, and this inside system, the roots from the plant is directly in touch of the water. Next one, see. So in case of deep water aquaponic system, this raft can be made from anything like thermocol, polystyrene sheet, anything that is non-reactive with the water. Suppose if we will use any reactive plastic, because water will be in touch with that, uh, you can say sheet. If it will be reactive, it will uh, cause some harmful things to the water. So whatever raft we are using, it should be non-reactive with the water. Second thing, uh, in that system, we can use some leafy vegetable like lettuce, basil, mint, and all. The depth recommended for this deep water culture system is about 30 centimeter to 40 centimeter, because that much amount of water will be enough to for the plant growth. So it's not so much deeper. Okay, and next one is that it should have a very high good strength and water holding capacity, and nutrient will be recycled by the means of pump. Next, you can see here the this is the tank. Inside water is there, and the roots of the plant are directly in touch with the water. So in that case, uh, this nutrient absorption by the roots is very high. You know why? Because roots are directly in touch of the water. So so the absorption of nutrient from this water will be very much higher as compared to NFT, where there is nothing to support the roots. Water just continuously flow, and the waste will be taken in a very slow manner. Next, in deep water systems, water ratio for fish tank and grow bed is 1 to 1, and the grow bed should be have a air pump to make a current inside the water, because if there will be no current inside water, nutrient will not come at the top, because nutrient will be settled, the waste will be settled down to the bottom. So that need to be circulated, so that all this waste will be in circulation and suspension condition. So if the waste are in suspension condition, it can be easily taken by the plant roots. Next, same thing you can see here. Next one, see. So inside the aquaponic system, what we usually have is a mechanical filtration and biological filtration. Suppose if you are having a fish tank, the fish waste will be in a high amount. So that fish waste should be initially filtered by the means of mechanical filter, and then it will be filtered by the means of uh, bacteria in by the forms of biofilter. So in the case of mechanical filtration, it is the basic primary filtration. What we used to do by this filter, we used to remove the solid waste from the water. Okay, if the solid waste will be there, it will create the harmful gases. So by the means of mechanical filter, we used to remove the solid waste, and if we will remove the solid waste, this will not have the harmful gases, and it will also help to make the continuous flow of water, and root can take the nutrient in a very efficient manner, and it can be very healthy for the fish. So there are various types of mechanical filter, like swirl filter or radial flow filter. These mechanical filter basically filter about 60 to 70% of solid waste. Okay, so after this mechanical filter only, the biofilter will works. If you are having a very big farm, there will be very high amount of solid waste. So we need to have more or you can say a big number of mechanical filter, because more the waste, we need to have more mechanical filter. So that the mechanical filtration depend upon the how much scale of aquaponic system we have. Suppose we are having a very small unit, there there we need very small amount of mechanical filtration. And and next is we need to regularly clean and maintain this filter, because if you will not uh, make proper maintenance of the mechanical filter, it will be get choked by the waste, and it will be clogged, because it used to separate the solid waste from the water. So it need to be regularly clean up, and so that it may not have a clogging of the waste inside this filter. Next, see, in that you can see this is a swirl filter. So swirl filter is that the waste comes from the water at an angle. You can see here there are various types of pipes that used to rotate. So as these pipes will rotate, the solid will go down. है ना? Suppose if you are having a waste inside that pipe, and it is moving, this waste will come down by the means of gravity, and it can be easily separated by this. Next is the uh, mechanical filter by the means of baffles. See here what happens. Here whatever wastewater comes in, it is immediately directed in a downward motion. And because of these baffles, the solid directly settle down to the bottom, and water can be cleaned, and then it can be moved to the top position. You can see in the diagram whatever that water from the fish tank, it is coming from the top and it's going from the bottom. And what we used to do, we used to uh, make this waste rotate from the downward, so that the solid will come down to the bottom, and water can be clean and can be recycled. Next, this is only the secondary filter. If you want some more mechanical filtration, you can have some secondary filter by the means of a sponge. So whatever solid is not removed by the mechanical filter, it can be removed by the means of a sponge, because the sponge will absorb all this waste, and the water will percolate and it can be recycled. Next, next is the biological filter. See, biological filter is nothing but filtering the filtration of water by the means of bacteria. So if you want to filter the water by the means of bacteria, you need to what we need to have? We need to have bacteria. So where will bacteria will grow? Bacteria will grow on a substrate. So in that biological filtration, we need to give the substrate, so that on this substrate, bacteria will grow. The more bacteria will grow, the more filtration can be done, and more efficiently and more quickly this filtration can be done. So what we used to do, we used to have a media inside biological filter which have a very high surface area as compared to the volume. So it can be means of any bio balls or bio drums or anything, or chips, or any, you can say, PVC made material which having a very rough surface, because rough surface will have the more surface area as compared to the smooth surface. Suppose this is a very smooth surface, so it will have a very less grooves. There will not be any gaps, so it will have a very less surface area. And suppose if we're having a very grooves curves, it will have the more surface area. Okay. So in case of biological filter, we used to choose the biofilters. Biofilters can be made from anything, by the made of ceramics, plastic, but anything that is non-corrosive, non-reactive, high surface area can be used to have a substratum for this biological filtration or nitrifying bacteria. Next, see, this is the small scale bio aquaponics biofilter. Next, this is the waste recycling in aquaponics. So how the waste recycles? So first of all, where from the waste comes? See, the waste will come mainly from the fish tank because we are giving the feed to fish. We are not giving any nutrient directly to the plant. So whatever feed we are giving to the fishes, fish will eat. It will have the fecal matter. It will also have the unutilized feed by the fishes. So that unutilized feed, which will also have a nutrient, and the fecal matter from fish, which also have the nutrient, it will be pumped to the plant bed. And in that bed, uh, there is a if you have a media system, it will have a substrate for bacteria. So the fish waste will have ammonia. Ammonia is very, very toxic to fish, and it is also somewhat toxic to plant because plant does not take ammonia in direct form. It needs to break down in the form of nitrate and nitrite. So first of all, ammonia, that is NH3, will be broken down by the means of bacteria called nitrosomonas. It is basically a bacteria which convert the ammonia to nitrite, NO2, and that nitrite will again be broken down by the means of bacteria called nitrobacter. It will convert NO2 to NO3, and that NO3 is very less toxic, and plant can utilize this uh, nitrite in a very efficient manner. And this water will again would go to fish tank. So this nitrite is less toxic to fish also. So what we have in that waste recycling, we used to recycle the ammonia that is very high toxic to the less toxic nitrite in the intermediate nitrate. Okay, and that can be utilized by the plants. Next, next is the water filtration. So as I have told you, this plant root will filter out the waste from the water, and the rest water will go to fish tanks. Same thing is with the chemical filtration because the fish waste provide the necessary nutrient for the plant growth. There is no need to have a synthetic chemical filtration because if you will have a chemical filter, this waste will again go to fish and plant, and that chemical filter will harm the fish as well as plant. So in that aquaponics, we mainly have a mechanical filter to remove the solid waste, and waste will be broken down by the means of bacteria. Okay, and in that system, we can minimize the waste. Next, next is the algae in the aquaponics. See, algae also play a big role in aquaponics. Suppose from where algae will come. If there is a very high nutrient, or we can say the less decomposition of waste, algae will grow. The more algae will grow, it will hamper the plant growth as well as animal growth. So in this aquaponic system, we used to control the algal growth. So if the algae will be high, uh, it will hamper the plant as well as fish growth. So we need to control this algae uh, by the means of control over the pH, dissolved oxygen, and physical obstruction. Next, so these are the basic system that how you we can have the more bacterial colony. So for the more bacterial colony, the basic system is that we need more surface area where bacteria will be attached, or you can say adsorb. Adsorb means surface attachment. है ना? Absorb means inside absorption. Adsorb means surface attachment. So more surface area means more attachment of bacteria on the biofilters. Next, main purpose is the bacterial growth. So more surface area means more bacteria will be attached on the biofilter. Next is the water pH. So if the water pH in the aquaponics is between 6 to 7, it is very optimal and bacteria will grow in a very high and efficient manner. Next one is the temperature. Temperature is that if the temperature of water is between the 17 to 34 degrees Celsius, the bacteria can proliferate or divide in a very efficient and very quick manner. So we need to control this water pH and temperature so that we can have a very good amount of uh, bacteria. I will uh, tell you the answer of all the question at last about the costing of aquaponic system. Next, next is the dissolved oxygen. Because I have told earlier also that bacteria also need oxygen for their survival. Like if any water body have a very high BOD, that is the very high biological oxygen demand, means if very high amount of load inside the water, bacteria will need more oxygen to decompose. So if there is less oxygen inside the water tank or any water body, this uh, you can say the process of filtration will be slower. So we need to have a ample amount, that is a 6 to 8 ppm of water, 6 to 8 ppm of oxygen inside water, so that in 6 to 8 ppm of oxygen inside water, bacteria will work very in a efficient manner and can easily decompose the waste. Next one is the ultraviolet light. Nitrifying bacteria or the bacteria which decompose this waste uh, can be hampered by the UV light. So initially, what we used to do in aquaponic system, we used to prevent the sunlight from so that bacteria will not be hampered by the means of UV light or sunlight. And bacteria colony needs some time so that they can grow. It's not like that once you're having a biofilter, bacteria will grow. Bacteria needs about 1 week to grow on any substratum. And after attachment only, they will work in a efficient manner. If they are not attached to any substratum, it won't work. Next. So this is that fish and plant, whatever we are having in this aquaponic system should be compatible. Suppose we are having a fish that is not tolerable to high temperature and plant is tolerable to high temperature, it won't work. So we need to think in mind that whatever fish or whatever plant we are going to have in aquaponic should be compatible in case of water pH, in case of temperature. Accordingly, we can have. Next, see, I've told you earlier also that in some aquaponic system where there is a high nutritional demand, some plants like tomatoes, pepper, cucumbers, beans, peas, they can be grown easily. But in plant where there is a less amount of nutrient, only leafy vegetables can be grown. And next one is the fish. So we can have only ornamental fish or food fishes inside this fish tank, and that fishes should be this type. We can tolerate the low oxygen in high density. So any fish we can be survive in high density and low oxygen is best suitable for the aquaponic system. Next. This density is like suppose tilapia. It is very hardy fish and more suitable for the aquaponic system. It can be stocked like 100 number of fishes per cubic meter of water. And inside this aquaponic system, you can have a 4 to 6 months of culture, and you can have it for 365 days of an year. So you can daily you can harvest the fish and plant. Next. This is the water quality for this aquaponic system, and this water quality you can just note it down. It's suitable for both the fishes and plants. So this is like 6.5 to 8.5 DO should be there. Nitrites should be about 0.03 to 1.16. Ammonia should be almost as low as possible. pH should be about 8, a slightly alkaline pH, and temperature should be around 25 to 30 degrees Celsius is very optimal and ambient for this aquaponic system. Next. So main challenges. Till now we have discussed about why we need to do the aquaponics. We have learned a lot about aquaponics, but there are some challenges, or you can say the disadvantage. The main thing is that it having a very high initial setup cost. It may vary from 10 lakh to 15 lakhs to about 5 to 1 crore also, depending upon the area and the types of aquaponic system that that we are going to make. Second thing is that we need to have a very sound knowledge about the aquaponic system, because if you not maintain the water quality, it may lead to the failure of the system. Third is that we need, since it is a very closed system, we need to have the power backup. We need to have the oxygen generator, the water filtration unit, bulbs, you can say water circulator. So we need to have a very high energy consumption inside that. This inside aquaponics, there are very limited crops like leafy vegetables, small plant can be grown. So this is some of the limit things. And next is the disease or pest management or the stability of farms. Next. So this is the future trend. Now, what we need to have, this aquaponics is a very, very simple system. You can do in a very, you can say, efficient manner, like NFE technique, media bed technique, floating system things. So what now we need to do? So for future things, we need to have the more modernization or more automation of things. Suppose if you're having a very small farm, you will do the daily manual checking of water quality. But if you have a very big farm, you cannot do it manually, or you cannot rely on the manual practices. You need to have the automation, or you need to have the uh, machinery that can be automatically operated. So this thing, if you will use the renewable source like solar power energy, we can think in future to use the aquaponics by the help of the solar power system. Next is that this waste from one system will be utilized by the other, and next is the synergy with vertical farming. Like in NFT technique, we can go in more vertical manner so that in case of urban areas, it can be done in a very good manner. We can have a multi-layer system. So these are things are the future trends. We need to work on these trends in future times so that we can have a very big or very efficient farms in the urban areas also, where there is a lack of lands and other things. Next. We need to have a commercial expansion also, because unless and until we will not go for commercial expansion, it won't be profitable. So in future we need to expand it at a very commercial level, and we need to use it as a global supply for food. We need to make it the more scalable things so that it can have a very good output of food and income as well. Next. Next is that climate resilient. As we all know that we are having the problem of drought, floods, or some extreme temperature things. So if we have a very good compact climate resilient system of aquaponics, it can be a good alternate for food production at present scenario. Same thing is that from urban food production, urban agriculture, or vertical farming, we need to empower, we need to educate the people to go for aquaponics, because it is a very good system in which we can have plants and fish at one time with low investment with organic food. Next, next is that we need to have a artificial intelligence AI, because by the means of AI, you can optimize the aquaponic system, that how much humidity, how much temperature is needed by our plant and our fishes. So you can automate it by the means of AI in the future times. So we need to incorporate the AI inside aquaponics so that there will be very less chance of failure of aquaponics. Everything will be maintained and by the means of machines, and there will be good security. There won't be any failure of aquaponic system. We need to also have a good genetically engineered plant which will grow very higher in less time. So all these things we need to work upon for the future times. Now, at present, we are doing in a very simple traditional method of aquaponics. But as time will grow, we need to work on this aspect so that we can have a very good commercial automated running aqua farms. Next, government also need to provide some incentive. They need to educate the people so that more and more people will come in this aquaponic system. We need to collaborate with some private ventures so that it can be spread in a very efficient and a very timely manner. Next one. Next one is the innovation. We need to innovate things, like we need to can say have a genetically engineered plant, hybrid types of fishes, which will be very hardy and very useful, a very you can say uh, useful for this aquaponic system. So we need to have innovation in technology like automatic sensor-based things. Like if we're having aquaponic system, if we're having a sensor for temperature, humidity, ammonia control, nitrite control, diesel oxygen, so everything can be uh, done in a very efficient manner. So we need to innovate and we need to work on these technologies and automation of these things. Next. Like we need to have the energy efficient designs, we need to have the integration with the smart agriculture system, and we need to have a modular or scalable system by the means of technology or by the means of sensors, AI in this aquaponic system. Next. The things to remember is that main things in aquaponics is the management of nutrient. So if we will manage the nutrient in a very good manner, then only we can have a good fish production or plant production. If the nutrient management will be poor, the excess nutrient will lead to the algal growth. The excess nutrient will hamper the fish life also. Suppose there is very high nutrient inside this fish tank, fish won't survive. There will be excess ammonia inside the tank and fish will die. So we need to have a very good management of nutrient, and we need to have a very good circulation of water, like monitoring of water, the speed of water, the amount of water pumped by the system. So all these things we need to remember in aquaponics is the nutrient management and this system or automation of the system. Next, this tip and tricks like regular monitoring of pH, dissolved oxygen. We need to have prevention from direct contacts of sunlight to fish tank. Water changing should be in optimum, like 30% water should be changed, not more than that. If you will change more water, it will hamper the plant growth. Next. So this you can see this urban organic. This is a very good aquaponics farm in the USA. Second one is Sky Greens. This is in Singapore, and third one is the farm of Spain. So I just want, I have given this picture just to imagine that how bigger they are doing. And in India, we don't have such a bigger operational farm. So we need to learn from these big farms that and how they are doing this at a very high commercial scale. So we need to work, we need to learn from this aquaponic system, and we need to have this system in India also, so that we can have this type of system in India. Next. Thank you.